All right, we're in section 6.2 and we're dealing with triangles in this section, triangles and angles. And the first thing that I want you to note once again is there are several new vocabulary. And in this chapter, I want you to write the vocabulary down. This should be part of your notes because these are the things that are going to catch you on the test if you don't pay attention, because there's so many new terms. There's just a lot of things that we need to be aware of in this particular section here. So make sure that at some point in time, either right now or at the end, you write down all of these vocabulary words, because these are going to be key things for this section. All right, first of all, let's talk about a triangle. I think most of us are familiar with what a triangle is, but by definition, it's a figure that's formed by three line segments that intersect at their endpoints. So here's line segment 1, line segment 2, line segment 3. They all intersect, and we usually name them based on the letters of those intersections. So this one is example triangle LMN, and we usually write that with that little triangle symbol, LMN. So there's my triangle, and so on. Key things about triangles, just to make sure that you remember some of these things that we've probably talked about before, but if you have a triangle, all the angles together add up to be 180 degrees. So the three different angles will total to be 180 degrees no matter what. And now the nice thing about that is that allows us to find a missing angle. If we know 2 out of the 3, we can figure that out. So let's take a look at this first example. We've got one angle, which is 72, one 74. One of them is unknown, and we know that the total has to be 180. So we could say that 180 equals 72 plus 74 plus x. And this is a pretty simple problem altogether. We're going to end up with 146 when we add these two together. So 180 minus 146 is going to give us 34. Okay. All right. Now we can classify triangles. Usually we do this in two different ways. One is by their angles, and the other is by the sides. So let's take a look first at angles. If we want to classify this angle, and we know that there's always going to be at least two, there'll always be at least two angles that are less than 90 degrees in here. Whenever you make a triangle, you can't have more than one that's bigger than that. So we classify it by that third angle. So obviously there's going to be two that are smaller, and we take a look at that next angle, and that's going to tell us a little bit about that triangle. If that angle is less than 90, then we call that an acute triangle. Once again, remember we talked about acute angles being less than 90 degrees, so an acute triangle would be one that contains all angles less than 90 degrees, which would all be considered acute angles, so it's called an acute triangle. If we have one angle that is greater than 90 degrees, that is known as an obtuse triangle. It's an obtuse angle, so it becomes the obtuse triangle. And then the third option is the one that we've probably worked with quite a bit already, and that's if it has a right angle, and then we would call that a right triangle. So in measuring that or classifying them by angles, we have acute, smaller than 90, obtuse, greater than 90, right if it is 90. Those are our three triangles. If we want to classify them by sides, we're going to classify them as to whether the sides are the same or are they congruent. So in our first example, none of these are the same. If you were to measure them, every single one, this one's the shortest one, this one, I don't know which one. This one's probably a little bit longer, and so on. They're all different. All three of them are different. And the term for that, when all three sides are different, is that they are known as scalene triangles. Then it is possible to have one where two sides are the same. So in this example, this side and this side have the same length. And you can tell that, they indicate that in geometry in this book and in almost everything, I guess, by putting in what they call tick marks. These little lines right here are known as tick marks. And when you see them and they both have just one tick mark in them, that's to tell you that those two lines are congruent. So in this particular triangle, it has two congruent lines, or two congruent sides, and therefore that is known as an isosceles triangle. Two congruent sides, isosceles, and if we have all three of them exactly the same, we have a tick mark in each one, three congruent, then we have an equilateral triangle. So scalene if none of them are the same, isosceles if two of them, equilateral if all three of them are exactly the same. Okay, let's take a look now. Let's go on here and take a look at our sample problems. It says classify each triangle by its angles and by its sides. All right, so if we do angles, if we look at this first angle, it looks like 38, 71, 71. All of those are less than 90 degrees, and if they're all less than 90, then that's an acute, they're all acute angles, therefore it is an acute triangle. We'll just make a little triangle symbol there. And if we look at the sides, notice that there's one side that's the same as the other one. Therefore, if you have two that are the same, we have an isosceles triangle. So in this particular one, they are all acute, so it's an acute triangle if we're talking about angles, and it is an isosceles triangle if we are talking about sides. In our next one, if we look at angles, as soon as we see that right angle, then we know that we have a right triangle. So that's kind of an automatic thing. This is a right triangle. And then if we look at the sides, it doesn't look like there's no tick marks, and there's none of them that are same, so therefore it is a scalene triangle. And one thing that you may start to notice this is if you go back to this one here, it has two sides the same, it also has two angles that are the same. And down here, it has no sides the same, it has no angles that are the same. In order to have the same side, same length, the congruent sides, the angles do have to be the same. So those things are, that's just not a coincidence on that. That's just the way it is. All right, so your turn. Let's go ahead and do A, B, and C on our triangles here, and we'll check back in with you in a little bit. Make sure you do them either both by angles and by sides. Okay, so do angles and sides. Okay, for the first one, by angles, you would say that this is an acute triangle. By sides, you would say that it is a scalene triangle. On the second one, by angles, we would call that an obtuse triangle. And by sides, you would call that an isosceles triangle. Spelling on that one's interesting. Yeah. Okay, and the third one, all of them are less than 90, so therefore it is an acute triangle also. And they are all the same, three tick marks, so we have an equilateral. And you will find out, at least you might notice that all equilateral triangles are going to be acute because they have to be less than 90 in order to total up to be 180. Okay, so I guess you are ready to go. Short section, probably make up for the last one.